Liquid in glass thermometers are based on the linear relationship between thermal expansion of some liquids with temperature. A typical liquid in glass thermometer looks like this. The first thing to notice is the bulb. The bulb serves as a reservoir for the liquid. Next thing you'd notice is the stem, which is made up of the capillary bore, which allows the liquid to expand through it, and the scale. There is also a bit of empty space at the top of the bore of the thermometer called the expansion chamber. And this serves two purposes. First, to allow for expansion of the mercury when placed in temperatures slightly above the intended range. And secondly, it is either a vacuum or filled with dry nitrogen. The dry nitrogen has the added advantage of not only preventing oxidation of the liquid, but also applying a little pressure to prevent the liquid column from separation. The two most common liquids used in liquid in glass thermometers are mercury and alcohol, with mercury being the more common. Both of these liquids have their advantages and disadvantages, which we will explore. Mercury remains a liquid between minus 38 degrees and 356 degrees Celsius and is suitable for measurement of temperatures within this range, while alcohol is liquid between 77 degrees and minus 114 degrees Celsius, making it more useful in measuring lower temperatures. Mercury is toxic and not easy to find, while alcohol is not toxic and it's readily available. Mercury is opaque and can be seen easily, while alcohol is colorless, so it must be dyed to be seen. Mercury has a higher thermal conductivity, which means it responds to temperature changes quickly. Alcohol has a lower conductivity but has a higher thermal expansion. What this means is that while it expands slowly, a small temperature rise will cause a greater rise in the bore than for the same volume of mercury. There are two special applications of liquid in glass thermometers which we will discuss next. First, the clinical thermometer, and then the minimum and maximum thermometer. The clinical thermometer is used for measuring body temperatures. Its unique features start from the bulb. Most clinical thermometers have a metallic cover around the bulb to improve heat transfer for faster readings. Next is the scale. The scale is also different because the acceptable body temperature of a healthy human is 37 degrees Celsius. So the scale ranges from 35 to 43 degrees with smaller fractions in between for more precise readings. The 37 degrees Celsius point is usually marked with a red arrow. The most prominent feature is the constriction in the bore, that is between the bulb and the beginning of the scale. During a temperature reading, this bore prevents the liquid from falling back down in the column immediately the thermometer is removed from the subject and makes it easier to read the maximum temperature that was reached during measurement. A quick shake will move the liquid back into the bulb before taking the next measurement. And next is the combined minimum and maximum thermometer, which finds its major application in weather stations, where it measures the maximum and minimum temperatures for the day. This thermometer has a U-shaped stem connected to two large bulbs. Both bulbs at the end of the U-shape contain alcohol, while the middle section is filled with mercury. Also notice that at the minimum temperature section, the bulb is filled with alcohol, but at the maximum section, there is an air gap to allow for alcohol expansion and evaporation where possible. The scales of the thermometer are placed on the straight sections of the U-shape. To make recording the extreme temperature points easier, two steel indexes with springs float in the alcohol to serve as markers for the extreme positions of the alcohol. Let's go through the process of how this works. So let's say the maximum and minimum temperatures of a city on a given day are 30 and 10 degrees Celsius respectively. The increase in temperature will cause the alcohol to expand, pushing the index and the mercury around the thermometer. The scale reading on both sides of the tube is always the same. So in this case, at the highest temperature, the thermometer reads 30 degrees Celsius. As the temperature begins to drop, it causes the alcohol to contract. Mercury moves up the minimum arm, pushing the minimum index upwards until it reads 10 degrees Celsius. Note here that it is the expansion or contraction of the alcohol which measures the temperature. The mercury indicates the temperature reading on both scales. A magnet is used to reset the indices by bringing them back in contact with the mercury. Liquid and glass thermometers are popular because they have a simple, low-cost design that operates without the need for any kind of electric power. However, their accuracy and range are limited, and the response time is slow compared to other forms of thermometers, which we will discuss in other lessons. See you soon.